Hello. This is a Sudoku that I came up with back in October that I posted on Facebook, Logic Masters Germany, and the Cracking the Cryptic Discord server. It's one that people who tried it have found quite tricky. It's only had 7 solves so far in Logic Masters Germany, and the tester on Cracking the Cryptic who tried it didn't manage to get very far with it. However, it's not all that difficult once you've got past the initial break-in. So I thought I'd do a walkthrough to show you how it works, what the logic behind it is, and how you can proceed once you've done so. So the Sudoku itself, you'll notice that I've got this motif of 4 thermometers in a box and 2 additional diagonal constraints, plus all these killer boxes, killer cages, and a couple of little killer clues. I'll just explain what these different constraints actually mean. The thermometers in Thermo Sudoku, they increase starting at the bulb end. So for instance, this one, you can go 1, 2, 3, 4, 5, 6, but you can't go 1, 2, 3, 4, 5, 6 in the other direction. And it's got to increase. So you could go 1, 3, 5, 6, 7, 8, for instance, but you couldn't go 1, 3, 5, 5, 6 because that doesn't increase. So that's the general idea behind the thermometers. Well, that's just my printer making some funny noises. The diagonals. Now, you know the usual Sudoku rules. You can only have each of the digits 1 to 9 in each of the rows, or each of the columns, or in each of the boxes. Diagonal constraints add an additional constraint here that you can only have the numbers 1 to 9 without repeating on each of the diagonals. So each of the digits 1 to 9 has to occur on this diagonal, and each of the digits 1 to 9 on this diagonal. Now, the other clues we've got are killer clues. Killer cages in Sudoku, usually they have a little number in the top left-hand corner. That number gives the sum of all the digits in the killer cage. The reason why there isn't a number in this Sudoku, this particular puzzle, is because all the killer cages sum to the same number, which you have to figure out what that is. So all these ones are 2 cells each, and there's one of 3 cells. Then you also see these little killer clues given by arrows at the side. Again, these are the sums of the digits on the diagonals. Boom, 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 boom. So again, these all sum to the same number, and you've got to figure out what that is. It's the same number as these ones. Now, digits in killer cages can't repeat, but that's a moot point anyway, because all the killer cages here are constrained to a single region, so they couldn't repeat anyway. Digits on little killer clues can repeat. So you could have, say, 1, 2, 2, 1, or something like that. That's perfectly valid. But obviously, something like this, 1, 1, that isn't. Obviously, that's different from these ones. The digits can't repeat in these main diagonals. So let's take a look and see how far we can get with this. See if we can get through it. First of all, we'll just take a look at these thermometers. These 4 thermometers. This is a motif that I've used in several of my several Sudokus that I've designed so far. If we just start off by filling in the numbers, if we just start filling in the candidates, 1, 2, 3, 4, 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9. And similarly for these ones, and Now, so that's all the candidates that we've got initially. First thing you'll notice is these 4 cells. Now, because of these diagonals, this cell sees that one, and that one, all 3 of the others. This one sees that one, and that one, and so on and so forth. So each of these 4 cells sees all 4 of the others. That means if one of these is a 6, none of the others can be a 6. If that's a 7, neither of these can be a 6 or a 7. If that's an 8, that can't be 6, 7, or 8, so that's got to be 9. Oops. Basically, in other words, these four cells, let's highlight them in orange. They form a 6, 7, 8, 9. Let's highlight them in a bit more subtle color, I think. Let's highlight them in green. That's a 6, 7, 8, 9 quadruple. So that's the first thing you notice. That's the first thing to bear in mind. Now, the next thing to point out, this one can't be a 6. Because if this was a 6, that would just be a 6, that'd be a 7, that'd be an 8, that'd be a 9. What would you put in here? So these ones, they can't be 6s because these thermometers are symmetrical, which means these ones, because the highest one here is, these ones can't be 5s, and these ones can't be 4s. So that's the first thing you notice about these. Now, the next question, where can you put the 1s in these corner boxes? That's what we're going to look at next. Before I attempt that, one of these thermometers is, because of this quadruple, one of these thermometers is going to end in a 6. And the one that ends in a 6 is going to go all the way down to 1, like this, 6, 5, 4, 3, 2, 1, forcing a 1 into this box. So, where does a 1 go on this row? It can only go here, because it can't go anywhere else in the thermometer, because if you put 1 here, you'd have to have 0 to the right of it, which you can't do in Sudoku. This is a general rule of Thermo-Sudoku, by the way. The only place you can put a 1, if there is one on the thermometer, is on the bulb end. And similarly, the only place you can put a 9, if there is one, is on the far end. So in this row, there's just 2 places we can put a 1, either here or here. So now, because we can't put it here, obviously, because of that one there. So now, where do we put a 1 in this column? You can't put it here because the 1s are constrained in this box to those 2. So it's got to go in here, one of these 2. And by the same logic, you can't put a 1 here, so a 1 has got to go in one of these 2. Now, the next question, where do you put a 1 on the diagonals? You can't put a 1 in the diagonals in this box, here, or this box, or this box, or this box, because we've constrained the positions of the 1s. So the only place you can put a 1 in this cell is, in this box, is on one of these cells. But you need to have a 1 on this diagonal, and you need a 1 on this diagonal, but you can only have a single 1 in this box. Therefore, that's a 1. Now, that being so, let's just highlight the positions of where we can put it. So, let's just revert that to get rid of that 1, 2, 3, 4, 5, 6, and let's just mark the places where we can have 1s, and obviously that's a 1. So next, let's turn our attention to what can be the value of x. Well, the maximum you can have, you've got most of the killer cells, most of the killer cages are just 2 cells. Now, the smallest value you can have in a killer cage is if you have a 1 and a 2, a 1-2 pair. So that sums up to 3. But obviously, we don't just have 2-cell killer cages. We've got this one, which has 3 cells. That can add up to 1, 2, or 3. That can be a 1, 2, 3 pair. So the smallest value for a 3-cell killer cage is going to be 6. And now what about these little killer clues? Well, because of the restrictions on where we can put a 1, this 2, the smallest you can make that is going to be a 2-3 pair. And the smallest you can make that is going to be a 6. 2 and 3 is 5, and 6 is 11. So your smallest value for your killer cage is going to be 11. Now, what's the largest? Well, 2-cell killer cage could be 8 and 9, which goes up to 17. But we have 2 2-cell killer cages in this region of the grid, this 3x3 region. So the smallest we can make that would be if we took our digits from 6, 7, 8, and 9. Oops. So if you add up all these digits, 6, 7, 8, 9, that's the largest you can make these 2 killer cells. That sums up to 6 and 7 is 13, and 8 is 21, and 9 is 30. So divide that by 2, and that gives you 15. So the largest value for x is 15. But if x is 15, you've got 4 digits in 4 cells, 6, 7, 8, and 9. This one is also 6, 7, 8, 9. So you're trying to get 4 digits, 6, 7, 8, and 9 into 5 cells, so that doesn't work. So clearly, it's not 6, 7, 8, 9. Could it be? So could x be 14? Now, if you're going to do that, you'd have to make these 5, 6, 8, and 9. Why not 5, 7, 8, 9? I hear you say. Well, 5, 7, 8, 9 would add up to 29 and a half, which means I would add up to 29, which means each killer sum would have to be 14 and a half, which doesn't work. So you could have two killer cages with value 14, making that 5, 9, and that's 6, 8. But then you've got 5, 6, 8, 9. You've got 5, 6, 7, 8, and 9. 5 digits, and you're trying to squeeze them into 6 cells. So you've got 5 numbers that you're trying to put into 6 cells. Again, that doesn't work. So obviously x isn't going to be 14. Can x be 13? Well, if x is 13, there's 3 ways of making 13 out of 2 cells: 4, 9, 5, 8, or 6, 7. So 4, 5, 6, 7, 8, or 9. Does that work? Well, so you've got 4, 5, 6, 7, 8, 9 here. That's 6 numbers, 6 cells, 4, 5, 6, 7, 8, 9. So you're okay here. And again, 4, 5, 6, 7, 8, 9. But let's take a look at this. You've got 4, 5, 6, 7, 8, 9 goes into here, 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 and here. Let's just highlight these. So that's 6 numbers in 6 cells here. That's a sextuple, meaning that on this thermometer, this has to be 3, 2, 1. Now let's do it up here. Got a little killer sum that sums to 14. Killer cage sums to 14. Again, 4, 5, 6, 7, 8, 9. And look at this, 4, 5, 6, 7, 8, 9. On these 6 cells, again, you've got 1, 2, 1, 2, 3. So you've got a 3 here, a 3 here, that doesn't work. So let's take it down one more. Let's take it down to 12. Now, with 12, you can do 2, 3, 4, 5, 7, 8, and 9. You can't do 3. You can do 3, 4, 5, 7, 8, and 9. You can't do 6 because 2 6s in 2 boxes. You need 2 6s in 2 boxes. Again, 3, 4, 5, 7, 8, 9. 3, 4, 5, 7, 8, 9. So let's do the same thing here. 3, 4, 5. This time you've got 3, 4, 5, 6, 7, 8, and 9. That, and that. So you've just got, so that's a septuple this time, 7 numbers in 7 cells. So this has to be, that would have to be 2 and a 1. And again, same thing applies up here. 3, 4, 5, 6, 7, 8, 9. So this would have to be a 1, and this would have to be a 2. And now that's broken. Why is that? Because you have a killer cell here, cage here, a killer cage here. And so where do you put a 2 in this column? You can't put it here, can't put it here, can't put it here, can't put it here. You can't put it here because because remembering x is 12, you'd have to have 2 and a 10, and there's no 10 in Sudoku. Similarly, 2, 10. So there's nowhere to place a 2 in this column. So that means that x can't be, that means that x can't be more than 11. But remember, we have a 2, 3 here as our minimum, and a 6. 2 and 3 is 5, and 6 is 11. That means x must be 11. Now, the next thing we can do here, this means we can fill in this thermometer. So that's a 5, so that's very tightly constrained. That means none of these is a 6. That's all 7, 8, 9. So that's a little bit better. Now, next thing, look, you've got 2, 3 pair. That's 1, 2, or 3. Can't be 2 or 3 because of the 2, 3 pair. So that's got to be a 1. Because when you've got a pair, when you've got just 2 digits in 2 cells, you can eliminate those 2 digits of candidates for every other cell in that region. So the next thing where this means we can place a few more ones now. This killer cell, you can't put a 1 there because it's 11. The smallest value you can have in one of these 2-cell killer cages is going to be 2. 1 plus 10 would be 1. You need 10 to make up the 11. So that means that's going to be a 1. Here you've got a 2-cell little killer cage, little killer sum, so that's going to be a 1. So that's placed all our 1s. So that means we've got 1s here, 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 and here. So next thing we can do is we can take a look and see what can we eliminate from the bottom row thanks to all this stuff up here. That's not going to be a 4. That's not going to be a 3. That's not going to be a 2. That's not going to help us that much. So that's at least a 4. So that's going to be at least a 5. That's going to be at least a 6. So 2, 3, 4, 5, 5, 6, 7, 6, 7, 8, 7, 8, 9. Now, that can't be a 7, because if that was a 7, if this was a 7, that would have to be an 8, that would be a 9. And what would you put in here? So that's not a 7. And we can say that by the same logic, look, we can eliminate 6 from this. So that's 7. Well, that's 7, 8, and 9. That can be a 7. This one can't. But this one, again, that can't be a 7 because you'd have 7, 8, 9 here, which would conflict with this one down here. So that can't be a 7. So there we go. That's that. So let's take a look what else can we do. Right. This one is going to be 7, 8, and 9. This one is going to be 7, 8, and 9. That one means this one is going to be 2, 3, or 4. Again, 7, 8, and 9, 2, 3, 7, 8, and 9, 2, 3, 7, and 4 is 11, 8, and 3 is 11, 9, and 2 is 11. But we've already got 2, 3 pairs, so that means that's got to be a 4. And that's got to be a 7, which means that's not a 7, that means that's an 8, 9 pair. So, what's next? Since that's an 8, 9 pair, that means that must be a 7. Now, this one, because of this little killer sum, this one is going to be a 2 or a 3. 2, 3, 8, 9. Now, that can't be this one can't be an 8. So that 8, 9 pair. So, next thing, let's take a look at this box. Let's take a look at these two cells. This killer cage, what can that be? It's got to sum up to 11, but it can't use 2, 3, or 4. So that means it can't be 2, 9, 3, 8, or 4, 7. It's got to be a 5, 6 pair. So this means we have a 5, 6, 7 pentuple, 5, 6, 7 triple rather. But since that's a 5, 6 pair, that means that's got to be a 7. So what can we say next? This is not 7, 8, or 9. 5, 6. This is not 5, 6, 7, 8, and 9, or 1. So these two have got to be 2, 3, or 4. This means to make this up to 11, that's got to be 7, 8, and 9. That can't be a 7, that's got to be an 8 and 9, because that 7 sees those two. So these two, 8, 9, that's a pair. Which both see this one. So that's got to be a 7. And that resolves the rest of this thermo. 5, 4, 3, 2, 1. Which means that's not 4, that's not 3, so that's 2, 3, 4, 5. Which means that's not a 4, that's 5 or 6. Right, so now we have a 2, 3 pair, an 8, 9 pair, a 1, 7, and so this one has got to be 4, 5, or 6. That can't be a 1, that can't be a 1, that can't be a 1, so place those ones. So this is going to be 4, 5, or 6. This one is going to be 5, 6, or 7. 4 and 7, or 5 and 6. So let's see what's where can we put a 1 in this box? You can't put 1 here, or here, or here. Okay, you can't put 1 here, or here, or here. Can I put it here by Sudoku? That means this is a 1 by Sudoku as well. Right, so let's take a look at this diagram, this little killer sum. 1, 1, 6, 7, or 8. 6. So let's add these up. 1 and 1 is 2, and 6 is 8. To make 11, that's got to be 3. So that was a 7. 2 and 7 is 9, so that would have to be a 2, or with that, so that would be 3, 2, or 1. But this one sees that cell, so that's got to be 1 or a 3, which means that one can't be a 7, because 1, 2, and 7 is 9. Add a 1 and 3, that's a 10 or a 12. So 1, 1, 6, 8. Now let's ask ourselves, which can that actually be? Could that be? Could this be 3, making this a 6? If that's the case, then that would be a 5, that would be a 4. This would have to be a 2 because it's in the same box as a 3. And then you have to make these, and then these ones would have to, these ones couldn't use a 6, so they'd have to be 4 and 7. The reason being, if that was a 6, then if that was a 5, then that would be a 6. If that was a so that's 4 and 7. So these two have to sum up to 8 to make 11, but you can't use a 2 or a 3 or a 4 or a 5 or a 7. 2 means you can't do 2, 6. 3 means you can't do 3, 5. 4, well, you couldn't do 2 4s anyway. 5, you can't do 3, 5. 7 means you can't do 7, 1. So there's basically no way of making that sum up to 11. So that's not a 6. That is an 8, and that's a 1, which means that's a 1 by Sudoku. And these two have to sum up to, which means that's a 9, that's an 8, that's a 9. So these two have to sum. These two have to sum up to. These two have to sum up to 10. What that means is neither of these can be a 5, which means one of these has to be a 5, because none of these can be 5 because it can seize that one. So these have to sum up to. So these have to sum up to 10 without using a 1. So it can be 2, 8. It can be 2, 8, 3, 7, 4, 6. 2, 8, 3, 7, or 4, 6, which is not very helpful at the moment. We'll come back to that a bit later. 1, 7, 9, 8, 5. Okay. So let's take a look at the next thing. Okay. This is a 2, 3, 4. This is a 5, 6 pair, because that's the only 2 digits left here. Well, that's a 2, 3 pair, so 1, 1, 8, 1. 4, 5, 6, 7. So what goes here? It can't be 9, or it can't be 9, 8. But it can't be 9, 8. So that means to sum up to 11, you've got to either have 4, 7, or 5, 6. But we've got 2 of these already. So these 4 are going to form a 4, 5, 6, 7 quadruple. 4, 5, 6, 7. That can't be a 5, which means that can't be a 6. That one can't be a 7, which means that one can't be a 4. That's either 4 or 5, which means we have a pair there. So that's going to be a 6, which means that's going to be a 5, because we have to have 5 in this row, which means that's going to be a 4, which means that's going to be a 2 or a 3. So 4, 9, 8, 7, 6. So if that's going to be a 4, that means that's going to be a 7. Oh, come on. And this means that that's going to be a 5, 6 pair. So what goes in here? So that's okay. So that's a 2 or a 3. Again, we've got the little killer sum. So that's going to be either that's going to be either 8 or 9, and likewise that's going to be 8 or 9. Right, so 7149856. This is a 2-3 pair. Four, 5, 6, 7, 1, 2, 3. This is going to be 8 and 9. 4, 6, 9, 1. 4, 6, 9, 1. Okay. Okay, that 9 sees that one, so that's an 8. Which means that's a 9. So you've got 4, 6, 8, 9, 1, 2, 3, and you have a 5, 7 pair here. It's starting to get straightforward. So this is going to be either 4 or 6. So 5 and 6, or 4 and 7. This 5 resolves. Sorry. That 5 resolves these two. 2, 3, 4, 5, 6, 7, 8, 1. That's going to be a 9 because that's a naked single. 1, 2, 3, 4, 9, 6, 5. This is a 7, 8 pair. And so this has got some 11 without using. So it can't be 2, 9. It can be 3, 8. It can't be 4, 7, or 5, 6. So that can only be 3, 8. So that's going to be that way round. It's eliminated from. It can't be 4, 7 because it sees a 7 from. It sees a 7 from this pair and a 5, 6, 2, 9. So 2, 9, 3, 8. 3, 3. 2, 9, 8, 3, 8, 6. So that resolves this 7, 8 pair. Well, that's 6 sees that, so that's a 4 and that's a 7. That's a 5. 8, 3, 6, 1, 4, 5. 2, 7, 9 are your 3 digits here. That's going to be a 9. No, that's 2, 7, 9, your 3 digits here. 8, 3, 6, 1, 5, 7. 8, 3, 6, 1, 4, 5. 2, 7, 9. Yes, and the only way of making them with that is 2, 9 pair there and make that a 7. So that's a 2, 9 pair. 3, 4, 7, 8, 1, 5, 2, 6, 9. So next, 8, 3, 1, 4, 9. Okay, so 7, 2, 9, 3, 8, 5, 6, 1. That's going to be a 4, which means that's going to be a 4 by Sudoku. 4, 4, 4, 4, 4. That's a 4 by Sudoku, which means that's not a 4, and that's not a 7, which means a 2, 3 pair. So where do we put a 4 in this one? That's a 4 by Sudoku. So that 9 sees that one, so that's going to be an 8, and that's going to be a 3, that's going to be a 2, that's going to be a 3, that's going to be a 2, 3, 2, 9, 2. So that's a 2, 6. That's not a 2. So that's a 6, 9 pair. 1, 5, 7, 2, 6, 9. 1, 7. Okay, 1, 7. That's a 3 to make that one up. 7, 3 is 10, 1's 11. That's going to 4, 9, 6, 5, 2, 1, 7, 3, 8. So that's a 2, that's a 3. That's a 3 because we've got that 2 there. 9, that 9 sees that 8, which we should have already gotten that. Sudoku. Now, 3, 5, 8, 4, 1. That's a 2 by Sudoku. That means that's a 9. This is a 6, 7 pair, which is resolved because that's a 6 and that's a 7. That 6, see, resolves that 5, 6, 5, and we are cooking with gas here. 9, 8, 5, 9, 4, 1, 3. That's got to be a 2. That's a 6. That's a 7. 6, 5. 6, 9. 6, 4, 10, 8, 1, 9, 7, 3, 5. 6, 2, 1, 7, 3, 5, 9, 4, 8. That's a 6. 2, 6, 5, 1, 3, 7, 3, 4, 8, 9. And that is how you do my all the same Sudoku. Hope you've enjoyed it. Thanks for watching.